Oh, look at that. It's done.
It's done. What? It only took 2 seconds.
So, interestingly, just by looking at these numbers, there's a lot of things you learn about the image. Number one, is the image virtual or real?
It's virtual.
Virtual. How do I know the image is virtual?
Because the distance is
Yeah,
negative.
because d sub I is negative. The second question, is the image inverted or upright?
It's upright. Because the height is positive.
It's upright. How do you know it's upright?
The height is positive.
Good. Well, because the height's positive, or the magnification is positive, and a positive magnification means the image is upright. Let me ask you this last question. Is the image enlarged, or is it reduced in size? How do you know it's reduced in size?
It's less than 1.
Yeah, because this number here is less than 1, it's 0.6. Your magnification is positive 0.6. So I want you to see that you get an image that's virtual, because, and I'll put in parentheses, because d sub I is negative. You've got an image which is upright, and that's because d sub I is negative, which means, the magnification, which is equal to negative d sub I over d sub O, is positive. And then finally, it's reduced in size because the absolute value of the magnification is less than 1. Let me ask you another question. With a diverging mirror, is the image always going to be virtual? Is d sub I always going to be negative? How many people say, yes, I believe the image will always be virtual? How many people, no, sometimes it could be real. Okay. Well, mathematically, what is it about the mathematics that assures you that the image is always going to be virtual?
F is negative.
What's that, Becca?
The F is negative.
Yeah, so because the F is negative, do you see that you've got a negative minus a positive? I mean, no matter what F is, no matter what D sub O is, you're always going to have a negative minus another number. A negative and a negative makes a negative. You see? Let me show you just visually. Hey, here's a diverging mirror. Is there anywhere any of you could stand such that you would be a real image? You'd be an inverted image. You know, I mean, everywhere. Even my finger, no matter how close I get. What's that?
Move the camera, that way the people at home can see.
What's that?
Move the camera, that way people who watch it can see.
Oh, so I should, like, okay, so no matter where the
hey there.
object is, the image is always upright, and the image is always virtual. Also, do you notice, are virtual images always going to be upright? Sure, because if you got a virtual image, what's d sub I? What sign is d sub I if you got a virtual image? Negative. And so when you stick it in the magnification equation, negative d sub I over d sub O,
That's
what do you
enough
get?
for today.
Positive. So are you getting used to the fact that virtual images are always upright and real images are always inverted? That's just an artifact of the magnification equation. So, I want you to just be aware of that. Okay, it is now time for you guys to do a ray drawing of this problem. And you're going to do it on the top guy up here. And let me show you freehand what your ray drawing should look like. And then you guys will do it more carefully.
I'm just going to take this. See, no more shenanigans.
Tell me,
Is the top one?
the focus is there, the center of curvature is there. Or not tell me, I just want you to notice that. So let's say my object is right here, okay? Let me show you what these three rays are going to look like. And then you'll do them more carefully. Ray number one, the one that goes through the center and reflects straight back, is gonna look like this, and then before it can get there, it hits the mirror and reflects straight back. This is ray number 1. Okay, you guys okay with that?
Yeah.
Okay, ray number 2 starts off parallel to the principal axis, and then this ray is going to reflect off that way. You see that? Because of the curvature of the mirror, the ray is going to reflect off that way. Well, in which direction does that ray go? I mean, how do I decide how this ray goes?
Think about the focal point.
Thank you very much. It goes in such a way that it lines up with the focal point. This is the direction it goes, right? So that it lines up with the focal point. This is ray number 2. And then finally, ray number 3, that's the one that goes towards the focus.
What's the distance?
So this ray is going to go towards the focus. But before it can hit the focus, what's that ray going to do? It's going to hit the mirror, and then how's it going to reflect off? This is ray 3. It goes towards the focus, but before it can hit the focus, what's it going to do? Yeah, it's going to reflect off parallel. And that's ray 3. And so now my eye is right here, and I see those 3 diverging rays, so what am I going to do?
Connect
Freak
them.
out.
Yeah, back them back, track them back. So this parallel guy gets tracked back like this. This one towards the center gets tracked back as it goes towards the center. And then this red one that was, keying on the focus goes back towards the focus, and where they intersect is your image. So now, please do the ray drawing on the top of the back page of your mirrors. So this top guy here, yes.
The top one on the back page.